there's a lab that's, well, a couple of labs that Docker have launched. It's been around for just over a year. They've revamped it because of the Windows container stuff. So I'm going to go through one lab so you can see exactly how easy it is and what's involved, and hopefully it will be used to play around with. Cool. So without further ado, just to give credit where credit is due. A lot of the stuff that's done for tonight is sponsored. So Derivka has sponsored us the capability of using this event venue. So kudos for them. Obsidian have paid for some food, which is on its way. Also, the Subway sandwiches were sponsored by the Azure meetup, if I'm not mistaken. Also, GitKraken, which is a Git tool, have sponsored some t-shirts, and there's a t-shirt in the packs, and one extra one for free that we'll hand out as well. Ranch is also one of our sponsors. They help us out with some t-shirts, some swag, some advice. In our last meetup, we had one of the engineers from Ranch themselves in the States remote in and actually give a talk with our attendees. And we asked them a couple of questions as well. And also, which is not here, is JetBrains. They're also a sponsor of ours, and Docker, obviously. And next year, we'll be getting some additional licenses for JetBrains products, which our members will be able to use. Okay, so Learn with Docker. Learn with Docker is a site that runs containers, naturally, that was launched to help people work with Docker and containers without having to install anything on their machine. I'll actually go to the site. I'm just waiting for it to sign in. It spins up a whole UCP environment for you. For those who don't know what UCP is the Universal Control Plane. That's one of Docker's products. So to set a record straight, some conversations have been saying that, oh, Docker is dead, this is dead, Kubernetes is the next best thing. Those are all true in certain respects. The concept of what Docker is, there's two major facets to it. One is the engine or the app that runs on your machine, and the other one is the company that has orchestration. UCP is their orchestration tool. It's their platform that allows you to run containers at scale, which does use Kubernetes now. And it does also support Swarm, which is their orchestration platform. The runtime that runs on your development environment is slightly separated from this product. There are two separate engines. Underneath, they use the Moby runtime, but what you see as a development environment is the free portion. It allows you to run Kubernetes clusters if you wanted to. It allows you to talk to Moby. It allows you to run Windows containers and stuff like that. That, in the near future, I do not foresee, and the community says that it won't go away. So that is not dead. The concept of the company being free and open source, that has changed. And I think that's what the whole shift in the community is like. The concept of what Docker used to be has changed to more production, commercialized kind of environment. So with this website, Play with Docker, what they've allowed you to do is it spins up a cluster, and you have a manager, 3 workers, and a Windows agent. This is a Windows machine for free. If anyone knows what licensing that costs, it's quite a bit. So you can actually run your Windows containers, play with them, and all the rest in this type of environment. If you don't use this environment for a certain period of time, they will shut down that infrastructure. So you can't run your Bitcoin miner on this thing. Please don't. Because eventually it'll disappear. It just gets, those resources get recouped, and it gets used for someone else that needs to learn about Docker and stuff like that. So as you can see, I'm in the terminal, and I can see my C prompt. This is an actual VM that's running. So, without further ado, let's just go quickly back to the presentation. So there's a couple of concepts that I want to just run through before we get to that lab. So, first of all, welcome. For those, this is the event. Just go to the next one. Short presentation. So, for those who haven't registered for DockerCon, you can get a discount, Meetup 20. Use that as your code, and you'll actually get a 20% discount if you want to go to Barcelona. It's going to be a lot of fun. The Meetup, the members for this event will be going to this DockerCon, and we'll be raising a couple of concerns that we've experienced over the year, some feedback from community members, which is you guys, the different members. We're going to actually ask them some of the hard questions, purely about the orchestration stuff, Kubernetes, where does it fit, how do we go, how do we use this, that kind of thing. So in January, there'll be another meetup at the end of January, and we'll give you feedback from that event. So you're welcome to join us. Right, so one of the biggest things is modernizing traditional apps. So MTA is a slang word that's been running around now for a while. And that's not new. Microsoft jumped on the bandwagon, it was the end of last year, introducing the Windows containers. It has evolved substantially since then. Microsoft has been one of the key players in actually making multi-platform containers. If you don't know what that is, you can actually target either Windows or Linux on a lot of the .NET Core stuff now. So you'll actually run the same Docker file, the same build process, both on Windows and Linux, which is pretty amazing if you ask me, because that means your code becomes agnostic to the environment, which is very cool. Who's played with .NET Core? Just out of curiosity. Do you like it? Don't like it? Is it good? What's missing? Honestly, what is missing in .NET Core right now in 2.1 that you can think of, that you haven't been able to do in legacy frameworks? Hey? Anything in .NET Core that you can't do right now in 2.0 or 2.1 that you can do in full framework.
NuGet package supports bad stuff.
Okay.
And for frameworks, good.
Just by referencing so other dependencies.
Yeah, you can't use a lot of the
okay.
packages.
It's a good point. Good point. What packages are you using?
On 2.1 specifically?
Yeah. Well, no, not specifically. I don't know if it's specifically 2.1.
I think from 2 you can add all your package references from like your legacy .NET, like 4.6 and those packages.
You can, but then you can't run like this. It won't work cross-platform.
Yeah, I mean that's obviously that code was written for Windows. So
Yeah.
Yeah.
Okay.
But just like generic packages don't have .NET Core support, so you start coding it yourself.
Okay, so it's the
fair point. Huh? Cool. If when you play with .NET Core, so you'll know that you can compile your .NET again. If it's all your code, you can compile the .NET code in the DLL. You can compile the DLLs on Linux if you want to. You can take those DLLs and execute them on Windows, and it's exactly the same DLL, which is pretty cool. So, but before you get to .NET Core, you want to take your legacy stuff, the ugly stuff, you want to take it across. So there's a couple of ways to do it. And there's a specific slide where they show you the different levels or different grades that you need to tackle that process. So breaking down the monolith, Docker Containers 101, running .NET apps in Docker, fixing performance issues. Okay. Docker 101. So let's just go through what's going to happen. So ideally what you want to have is you want to have each process in its own container. Now what will happen is when you start off this process, that is not what you're going to have. You might end up either doing one piece of it in a container or try to fit everything into the container, which is bad practice. What you want to do is leave what you can't put immediately over into a container, leave it on the host, just have your container talk to it. And then your easy ones you put over into the container. So like W3WP, your Windows executable, IIS, console, some sort of console app, SQL Server, exe, some sort of SQL instance. This becomes interesting. So here, they're trying to show you that cross boundaries is a little bit difficult between your Linux and your Windows systems. So a better way is to have it talk directly to the PowerShell exe, and it'll manage it for you. So this is where orchestration comes in. So this is a basic descriptor of how a orchestrator works. So in the beginning, well, just now you saw UCP. You would have a manager. A lot of them run on Ubuntu, or not necessarily Ubuntu, on Unix. The likes of Rancher works well on Unix, Mesosphere, Kubernetes, and all those, your managers. And you have your workers, your slaves. Your slaves don't necessarily have to be just Windows, and then you have a separate cluster for Ubuntu. You can now share that infrastructure between inside your cluster, because you're always talking to the Docker runtime. PS Docker. Modernizing .NET apps. Prereqs, .NET Framework, toolchain, MS Build, NuGet, as we explained earlier. Hosting environments, IIS. Nginx is also a nice one to use, and database SQL Server. Prereqs, you just need Docker. To get to the one slide. This is the one I was after. So this is your migration path. This is ideally what I want to point out to you. So when you download this progress of modernizing your applications, your legacy applications, you usually have to go through a whole structure. First, you need to migrate as is. So you can either take a piece of it or the whole thing as is, and you can port it over into a container. For very legacy stuff, you can do this with Windows Server Core version 10.2.1, I think it is, and there's a build number after it. That is a lift and considered a lift and shift. It's a 10 gig image, very heavy, it's got a lot of the frameworks baked into it. If you don't necessarily know what your application is architected, how it's architected, you would use that base image to do it. SQL runs very nicely inside there. Once it's up and running, you can take a Windows service that's .NET 4 and above, you'll be able to run it inside there. So you take that kind of architecture and try to put it inside a container. Why would you do that? Because technically, well, traditionally, a lot of those apps run on a host that might be out of service or coming to out of service, or you want to leverage it into more scalable environments, potentially the cloud, that kind of thing. So you could take your applications as is and put it in there. There is a tool on the web that was authored at one stage by one of the Docker captains. It's a VDI to a Docker image. So what it does, it reverse engineers your host, your backup of your VDI. It'll reverse engineer it into a compose file that has some Docker files in it, and it'll try and interrogate IIS, your services stack, so services.exe, that stack, and to try to find out which Windows services are there, and interrogates the environment host file. So it can actually try replicate what your VDI has got, and it'll spit out a Docker file, and then you can use that to run against this kind of thing. Some little tips and tricks that you can use. Next one after that, you want to start migrating some configurations over. Maybe you want to adopt some new runtimes like .NET Core, that kind of stuff. You want to extract out key dependencies and start actually getting into a point where each server's process is inside a container. Once it's inside of one container, then you can easily scale it out. And that's where you'll be in a nice place to potentially flip over some of the workloads over to Linux and keep some of the other stuff inside Windows containers. Okay. There's the lab. There's the lab now. Any questions so far? Any suggestions? Any ideas, thoughts, patterns? Sure. Shoot.
I've got a question.
Yeah.
You are moving that monolith to one massive container, something like SQL Server.
Yes.
Do you keep the database files somewhere else on the host, not within the container, or do they all go in there?
Very nice question. So typically a container is should be treated as a stateless environment. So you shouldn't persist any data inside a container, because if the container stops, especially if you run it with a --rm flag, which means remove immediately when exit happens, that workspace gets destroyed. So what you would do is SQL Server, I do this often on my development environments. I don't install SQL on my machine, I run containers for it. And what I do is I volume mount, and you actually attach your MDFs that way.
Okay.
You can use SQL Server on Linux and on Windows. So Microsoft have released images for both. I have noticed, which is kind of ironic, mounting MDF files works a lot better on the Linux ones than on the Windows ones, and that's because of the file mapping between the host and the container. So the reattachment doesn't always work as seamless depending on the type of the size of the MDF file. It doesn't reattach correctly when the container gets mounted and starts up. But that is how you do it. So what you do is, in your production environment, you would volume mount a external storage device, and when your container warms up, you just reattach that MDF.
And the same applies to like log files being written out. You put those to a UNC path.
Yes, 100%. You can also use other logging frameworks like Datadog and that kind of stuff, where you just pipe it out to another service.
Okay.
That is, to pipe it out is actually, in terms of what I'm seeing, the strategy for a lot of providers is that is the better way of doing it, instead of trying to share it on a network drive. Just pipe it out to something else. You can actually run Elastic with Kibana inside containers.
Yeah.
And then you can map it out that way. So for your app to surface out logs is very easy. If you need another Elastic, you just spin up another container that kind of, and you manage those kind of things. So in other words, what I'm getting to is pipe the responsibility to someone else.
Cool. Thanks.
So we have our container up and running. Let's go through the lab. So the lab I'm going to use is this one. Docker for beginners, Windows. So just to go back to this repo, this repository was authored by 6i. He's a Docker captain that actually works for Docker himself. So if those you don't know who a Docker captain is, so you get different kinds of rankings. You get community leaders, which I'm a community leader. Our responsibility is to start the conversation. Docker captains are similar to MVPs in the Microsoft world. They are the ones that help answer hard questions and that kind of stuff. I've actually met this person. He's very, very clever, and his blog on a weekly basis has Windows containers that are very nice to read. So if you ever get a question or you're trying to solve a certain problem and it's in the Windows realm, this is the kind of person, and I'll share it on the meeting notes. If you go to the events.docker.com, you'll see his link here. I'll also share it out for the other platforms, so you can easily find it again if you forget or whatever. It's just a very nice reference point. He's also on Slack. He's very approachable. If you ask him a question, technically he'll answer you, and he is an MVP as well for Microsoft. So anything containers, he knows his thing. I've actually asked him a couple of questions when it came to our build servers, and he answered me straight away. So it's a nice reference point, and it's nice to take away. So I'm going to use his Docker 101 for Windows containers. Again, we're going to go through a basic thing where we're going to go through some commands, and we're going to run two separate applications, a Twitter app and another simple app. And you'll see it's actually running. It'll show you the Docker ID of the container that's actually running, just so you can see that this is not voodoo, it's actual infrastructure that we're talking to, we're using. Right, so I'm not going to read this, I'm just going to go through some of the commands, and if you've got any questions, just let me know. So the command here, docker container rm --false and docker container ls quiet all. So effectively, if there's anything running, what this command is going to do is going to, rm is remove, containers, we telling the container, the Docker CLI, I'm talking about containers, remove, but force remove, so even if it's running, kill it. Any container, so it's now listing, that is running. So quiet means if it's in like a stale state, --all gives you both stopped and running containers. We don't need to run that right now. Okay, that's just a cleanup script. So you'll notice there's different types of images that are out there on the internet. A lot of them on Docker Hub. There's a couple of other private registries that are popped up. Azure's one of them. If you go to GitLab.com, you can create your own private registry, which is really cool because with other providers you have to pay for it. So if you want to write some code in a private repo and play around with stuff before you push out to your company, GitLab.com is a very nice place to do it. Nice private repos, you can push your images. There's no real file image repository sizes as of yet, and they give you 200 build minutes, which is pretty cool. And they run Docker and Docker, which means their agent is running Docker and it builds images, which is pretty cool. Virtualization is inception. So just to come back here, Microsoft /nanoserver, that is the Microsoft namespace in Docker Hub, right? That means it's an official Microsoft image. You'll see often there's these image names that says Joe blog /SQL Server. That means someone did something else to that base image and they've got their own executables happening inside there. Not ideal for production code. So you want to try to keep to the official ones. The Microsoft Nginx has the official images, Postgres, MySQL, Oracle, those vendors that they create, and you'll see as well when you go to the repo, there's usually an official stamp on it as well. Those are generally safe to use in your own build pipelines. So we're going to spin up a nano server, and then we're going to give it a host name. So, right? And we're going to say docker container ls all, so we can actually list it. Right? So if we can do this. Book and see fine.
Yep.
Cool. Now, apart from running the container, who knows what's going to actually happen?
What is a nano server? Is it just a watered down version of Windows?
Very good question. So there's two major flavors of Windows Server at the moment. There's a Microsoft Windows Server, and technically it's currently it's 2016, with 2019 coming out. That is your traditional bloated server without the GUI. Then you get Nano Server, which was a watered down, it's like Alpine in the Linux world. It's a server runtime that doesn't really have anything in it. You need to now enable stuff into it. It's very lightweight. I think the latest one is like 200 megs or something like that for the entire server infrastructure.
Is that the one that you put on Windows 10? It's not the same Windows 10 image, is it? The small one that you put on a Pi.
Yes, it is.
It is.
Yes. There's a flavor of the IoT that uses Nano Server. Yeah. So I executed the command and it spat out a number there. Does anyone know what happened? Sorry?
Created a server.
But if I do this, so Docker PS says list any container. Mark?
So it's pulled down a copy of the actual container image and it's created a container that's in a soft state, which is by default.
Yes. So it started, it had nothing to execute and stopped. So not very useful. But what you can do is you can pass it a command at the end of the run command. So as an example, if we had PowerShell installed on this Nano server, we could say Docker container run Nano server and pass it a script, and it would run the script, and if there was no errors, it will just come out of the container and would have run that. So you could do, without mounting a volume, you could say go download this and put it somewhere else, or build something, or you know, those kind of things. So it's a one-time execution, and then if there's no errors, it'll just leave it alone and die. So what you can do is, it's not in the slide, but I'm going to just show it anyway. Run -it. Horrible, sorry about that. -it. I didn't make this website. -it means now go into interactive mode, right? Now it'll attach the command prompt to the container, and there it is. Now I can say ls. I'm inside the container. So that's what's inside Nano server.
Okay.
Right. And to get out of it, you can say exit. It comes out of it. Okay.
So is that container now stopped?
Yes. Yeah. So if I do, which is the next command, I'll show you. So we say --or. Technically, you should see now 2 or more. There's my 2 containers. The first one that I ran the first time, and the second one that I ran in interactive mode. Okay. Now, what's pretty cool about this, now we'll go a little bit further into it. This is running, I didn't have to, I do have Docker installed, but I didn't have to install Docker on my machine, and I can play around with containers. Now, if the image that I want to work with is in a hosted environment, I can now pull that image and start working with it. There is a way of SSH tunneling into this environment, and then you can actually have your local machine talking to this. I haven't done it because there's some limitations in this infrastructure, in this network, to be able to do that. But if you're at home, there's a way. I'll try to look for the blog post and put it on the meetup notes. There's a way of actually SSHing into this environment while it's running. So you can play around with your own code, your own source code, so if you want to post it on the net. So, sorry, just to come back to this. So all it's done is said container, Docker container, ls, which is list. It's a Unix command, --or. Give me. That's why the first one, Docker PS or Docker container ls, will just give you running containers. And that's how you easily distinguish what the difference is. And there should be a state there, kind of stupid the way formatting is. There it says exited. And if it's running, it'll say running.
But no, so you pull down an image, right?
Onto that machine, yes.
Yeah. Well, onto that sort of abstract.
Yeah?
Then you ran it once.
Yes.
And it died.
Yes.
And then you ran it again. So now do you have two? Why is it giving you two? I don't understand what you do. Because do you have two versions of it now, or?
100%. So what's happened is, so an image. So just to clarify, a Docker image, which is that, is like a contract. That's to describe what, if I had a server called Nano Server, this is what it would look like.
Okay.
When I ran the container, it literally created a folder on the machine and put whatever I run inside this container in that folder.
Okay.
But it's mapped, the processes are secured and mapped off that only this execution of this this container can talk to it by default. I can tell it, I want you to be able to do this as well. So that's where you expose ports and a couple of other things. You can tell it, I'm allowing you out of your little sandbox.
Okay.
But by default, it's closed off. Nothing else can go in or come out of it, apart from this terminal execution.
Okay. Is that what that little grid is?
Yes. So this number is the folder.
So eventually you're going to have just a pile of those in a folder, and once it finishes, there's a cleans out that folder, so you're not going to have like 200, 200, 200, 200.
Very good question. So no, not by default.
Okay.
So that's where I mentioned a little bit earlier, I can do this.
You have to do that remove thing.
I can say dashboard, let's put it in the beginning. Best practice when you're testing and building, you just have -rm.
Okay.
That removes it automatically on exit
Yeah.
of the container.
Okay.
So what is the philosophy behind keeping the full container there all the time? Can you respin an existing one, or like, I don't get why they do that. You know, you want to log the fact that it happened, but why do you have the whole thing left behind?
Because maybe, here's a scenario, you have a website, and your website's inside a container. And then all of a sudden your host, now there are certain boundaries in this, is the machine that it's running on. So as much as a container is awesome, it can scale and everything's fine, you're still living within the boundaries of a virtual machine, or a machine, a physical environment. So I've actually seen this. I have a Droplet, or a DigitalOcean Droplet, it's a VM, and I'm running SQL Server on there, and I've mounted my volume and everything's cool, everything's 100%. But my SQL container keeps on dying on me. It stops, it doesn't remove it, but it just dies on me. So all I need to do is say, start up again. So I can start the container again, and there's my SQL Server again. So the use case is in two scenarios. One, something went wrong and you just want to start it up again. All right? The other one is, as a developer, I don't want to have this running all the time. So I can pause my containers, I can stop them, do something else, come back, start them up again, and I have my environment again. Very, very powerful concept when you're actually doing this kind of stuff when you're using a compose file. Because you can compose up and down your infrastructure. So for those who don't know what compose is you get a Docker file, and that is what you use to build this image. This one over here. That's described in a Docker file. So typically you have from Windows Nano Server, I'm going to do some stuff, and my entry point potentially might be my DLL of my .NET Core application. That's a Docker file. A compose file is if I have services, Windows service, and I have an API and a MySQL, and I want to string all these up, and I want them to stand up at the same time, I use a compose file for that. So then I can say Docker compose up, and I point it to either a file or just say compose up if naming convention is the same, and it'll actually create this infrastructure for me. And when I'm finished with it, I can say compose down and it'll rip it down again. Which is very nice, because if you're a developer, you might want to have, now again, attaching MDFs, you can do it inside your compose file, as I mentioned. So say now you have an application, a legacy application, and the owner of the application gives me a backup of the database. I can put it in, I can connect my source files to it, I can compose up, and I don't have to have another virtual machine that I have to worry about make sure that it's patched and it's updated and everything's working fine. And when it's done, I've made some changes to the SQL, so I've got to tell this guy about my changes because he's off sick today. Now, all of those problems go away because I can compose up my environment and I can rip it down when I'm done with it. Also, I can take that compose file and I can give it to the guy next to me and say, here we go, run this file. And up it comes. And he can have the same infrastructure that I've got. It's very cool. So that kind of is what the use case for that is. Oh, yeah, hostname was the command that I passed in. So that's why it printed out that number. That number there. I think it's that one.
So you basically asked for the host name?
Yes.
Okay.
No,
So that's actually a command. That's not. I thought you were actually naming your container.
You can do that as well. So what you can do, go back to this command, you can do dash that root. We'll take up IT. Dash name. Football. Oh, okay. I'll show you another command that's also useful. Dash D. So I typed in dash D, not that you can see it. So detach. What? Oh. There's already a container named football. There's that, sorry, I said it wrong earlier. That is where the folder location is, that char there.
Okay.
That's the actual identifier container. So now if I go to Docker PS, should have one. Nope. Alright, execute. Finished off.
So theoretically, you've got 800 megs worth of containers on your machine at the moment. Is that right?
No. That's it. That's a little thing. So Windows containers are larger than Linux containers. However, containers work on layers. So currently, each of these containers have one layer, so they're kind of like sharing the same infrastructure. So if I can describe this nicely, every statement. Let me show you a Docker file. It'll kind of make more sense. What did it say?
Yeah. So it's a very similar concept which involves that you're running your basic image, and your image is get up and make a sec, and now you're running a context of that image. The only configuration that changes within that context will essentially add on additional weight to that image. So essentially running a shadowed copy of that basic image without actually taking additional resources other than the container itself. Only once you make configuration changes or add files or source something will that container and the container will that container grow. But it'll be specific to the content of that container, essentially.
Okay, so it's basically just pointing to your image there.
Essentially, yeah. Essentially.
Each line in this file points to a folder that references to the parent folder on the file system. So if you've added another line, effectively you create another folder there, which effectively is another layer, like what Mark was saying. And the database, the Docker database or the cache is what allows it to point through so it knows exactly where the changes are. So in this scenario, from there to there, I've only created one layer, but I've executed 1, 2, 3 commands. So I've done 3 things inside of one layer, and I've snapped it. So now when it comes to this layer, it does a very similar concept, but now I'm changing the context again. Okay. So if this is where building becomes very useful. If I'd only changed here, which is copy everything in source to the container, so effectively I just changed my source files, all of that stays the same. So I don't have to do all of that other nonsense again. I just do this portion of here, which speeds it up. Which means this is the part that's growing from there. If that makes sense. So you'll see this very prominent in Windows containers because your base images are so large. 2016 LTS is 4 gigs. which is your base image. That's your server. Then you start adding your layers on top of that. I'm going to enable registry entries. I want to start with adding other dependencies, like I'm going to install Node as an example, if you ever wanted to do that. Those kind of things. That's when you start adding them on. And it can get to a point where it becomes unwieldy, like maybe a 20 gig image. And when you get at that point, you start rethinking what you're trying to do. You're like, no, this is not right. Then you might want to use a 16 gig base image. Then you can copy the outputs into a smaller nano server and then publish that out to repo. And that's where you need to start managing all your build servers and that kind of stuff. But in production, you wouldn't want to run a 16 gig file, base image. It's going to be too heavy. Answer your question?
Yeah.
Cool. Yep.
Just working one of our projects, we depend on a certain version of internet, and we are building it from source.
Building very,
So like we pull on the source of internet,
yeah.
we build that version and build our project from it.
Oh, okay.
Yeah.
Is it because they don't have that image running? Or an image for that version?
I'm not sure. I think it's something about that specific version of internet. And yeah, I'm not really sure if we can.
It'll be interesting. If there's no custom stuff, maybe do a PR for it. You know what I mean? Because
Yeah.
by you creating an image, you are effectively taking ownership of that entire infrastructure, that version. It might be something to look at too. I mean, that's awesome. Do a pull request and maybe they can also support it as well. If you know what I mean.
Yeah.
But that's pretty cool. So you're actually compiling from source.
Source.
Taking it on Linux though.
Yeah.
Okay.
So, no, I think why we're building from source is the base image wasn't like a generic Ubuntu, it was certain other versions.
Probably Alpine.
Yeah,
Okay.
we tried with Alpine and then on top of that we building it in some source.
Okay. That's pretty cool. Alright, I kind of did this already. So Docker Run Interactive is -IT. So you'll notice that a lot of the commands is it's either the full name or the short name. -IT. Well, -IT is a nice short way of doing it. You're doing a lot of commands. -interactive is doing the same thing. It's the same as Docker PS, same as Docker Container LS. And RM -RM is removed. Explain it. Alright. Just run the container. Just run it in. Slight change, I took away the command, so by default, Windows containers, they default to CMD, command prompt. You can, if PowerShell is installed in the Windows container, you can pass the PowerShell parameter, and it will start up the PowerShell exe at the same time. So if you use the PowerShell. So, just to get through, that's a PowerShell there, okay, like there. You just run this command.
CNL.
Yeah. Wait for it to air now. There we go. So, I mean, this is not rocket science. Effectively, all I'm doing is I'm running PowerShell inside a container, and it's listing all the features that's enabled here. So, because I passed the PowerShell argument at the end of the line, so that when you're having your run command, after your image, your first argument is the process that you want to attach to, and then after that you can pass it parameters to that executable. So this is useful when you're using containers for builds, and so now you have a .NET application or some sort of workload that you want to do. You can create a script. In Linux world, they usually use SH files, so script files, and they say, run this container, and I'm going to pass you this script, and the script is going to actually execute inside the context of the container, and it's going to have an output at the end of it. You can say -cp, which is Docker copy some executable, some result out of the container back into the host, or you can say -v, and you can mount the current location or any child location within my current context into the container. So that's volume mounting. Very useful when you building .NET applications in this context, also Node applications. So now in the Linux world, if you don't want to have Node version 10 on your build agents, you want to POC a concept, you can volume mount your source files, or you can copy into it, depending on how you want to do it, and you can actually do an npm build, npm start, whatever like that, or some awesome gulp, grunt, whatever the flavor of the web is at the moment. You can do it inside your container, and when you exit out, you'll have your artifact. Your build agent, your machine, your dev environment, whatever it is, had no concept of that version of Node that was installed. Very, very compelling. Same goes for the Windows containers. You can do the same thing. If you want to go forward, you want to say now you have some source files, you want to target for this specific test, you want to target .NET 2.1 SDK, because you want to do a certain compilation, make sure that my NuGet packages can install on that version as opposed to .NET 2. You can do that easily inside a container. Those are just some examples of use cases. So all I've done here is I've printed out the features that are enabled on this current container, which is based on the Nano server. As you can see, there's nothing. Pretty much. You can enable a lot of the stuff like Hyper-V or whatever. You would actually use PowerShell commands to enable it.
How would you do that? Like, how do you say, give me the web server? And then you just basically spin this up, do something, like host a site for 20 minutes, half an hour, whatever, and you play with it for the day, and you break it all down. Okay, and then tomorrow you've obviously got that enable web server in your script, right? And you just run that script again. So tomorrow I'll start that container up again and start your IIS web server up again. That's basically what you use it for.
100%. So there's two very nice, quick ways of getting the value out of containers. One is you specify your commands in your Docker file, like I mentioned earlier. And your Docker file is your contract of what the image or the infrastructure needs to look like. So inside your Docker file, you can say, from Nano server, I need to enable this web server feature. I'm going to copy some files across maybe my website or you can attach databases or reference points for databases inside your Docker file. You can do all that inside your Docker file, and you can say build.
Okay.
Okay, and that creates your image. Then you can say run, and the run will actually execute the container, and all that features will be already enabled on that image at that point in time.
Okay.
So that's the one use case, and that's how you actually end up deploying your container. So you never deploy an image, you deploy a container, which is from the specifications from the image, which is the Docker file. And that's where Kubernetes and Swarm and Compose files come from, is you reference an artifact, which is that image. So that's one use case. The other use case, which I'm potentially trying to do this while I'm doing it, but I'm trying to expose it, where you can run your integration tests inside your container. So you spin up a container that has your files inside of it, has your application, and you have some sort of executable, some entry point where you can invoke certain concepts. So say now you have a web API as an example, and you have a database, you spin up the two containers, and then you have some sort of command line executable or script, and you actually call that endpoint. Now, you can interrogate the IP address or the port, or you specify the port and the IP address of the containers at runtime. So you can do what's known as port binding or IP binding on Windows containers. And you tell it, I want you to always have IP address 10.0.0.1, which won't work, but as an example. Or you can say, I always want you to have port 2020 or 8080. That means your code can now interrogate that port or that IP address. And now I can say, run my integration test. And my integration test will be as if someone clicked on it and did some execution. Then I can save that as an output, and I can save it into the disk. And that disk can be a volume mount. So now, if you think of it inside a pipeline, I can now generate a report from a container of infrastructure as if I was going to run it inside a test environment on a VM and pipe it back into my result sets, which I can now surface out to either inside a Git repo, or I can flick it out on a mail, depending on how I want to surface this information. I can send it over to either the devs or the managers or whatever like that. I can actually give them this information. And that infrastructure was there only when I needed that infrastructure to be there. So I've now saved the company a whole bunch of money, because I don't have to have these floating VMs all over the show, and they don't have to look after it and that kind of stuff, because I've created it dynamically and I've ripped it away dynamically as well. So there's also another use case, but exactly that is. Any other questions? Any comments? Any thought processes? Yes.
Is there a use case where you would run the container 24/7 forever?
If it was in production, yes. Yeah. Oh no, definitely, yeah. So it depends on use case. Everything's always on use case. So I have, I'll show you. Hopefully it'll log in. So about 3 meetups ago, I mentioned about a little app called Portainer. I absolutely love this little app. The reason why I love it is it's very easy to run. It works very nicely on Linux, and they're starting to support Windows platforms as well. What it does, it talks to the Docker CLI directly. So you expose the TCP port for the Docker machine. So when you get into the whole way all of this works, is you get the Docker machine, which is the actual runtime. So that's your API. Then you get the Docker CLI, which is the little Moby whale that you see at the bottom of your screen. Those two talk to each other the whole time. And that's how you actually get everything running. So your Docker machine might be Windows or Linux. So if you've got Docker for Windows, you'll spin up a VM called Moby, and your whale, your terminal, will talk to that VM via the CLI. Make sense? So when you're doing...
Do it again?
Okay. So if I've got when I install Docker, I get a little whale in my tray, and I get this little menu.
Oh, so that's like a Docker server running on your machine.
So this is the CLI, this is the PowerShell and your command.
Yeah.
So there it says switch to Linux containers. When I enable that, what happens is, because I'm running Windows needs to know about the Linux kernel, because that's effectively how all of this works. So you get the kernel, both on Windows and Linux, and the kernel has certain system calls. Docker have written what's known as the Moby project that wraps over those system calls to the kernel. And they've exposed those system calls to this runtime. It's the EXE that has all the binaries inside of it, that knows how to talk it, and there's other scripts inside your system. So when I switch to Linux, Windows has no concept, apart from the subsystem, has no concept of Linux. So what they've had to do is to make it reproducible. Docker themselves, they created a little mini VM that uses Alpine. It's called Moby. Using Hyper-V, because that's my native virtualization layer, on Windows, it spins this VM up. Then that CLI will now talk to it. So when I say Docker run Nginx, it's actually running that container inside the virtual machine. Okay. When I say Docker run Nano Server, I'm running it on my Windows kernel. In most cases. There's another story where that changes. But for now, we'll keep it there. The reason why I say it is because Microsoft have now released another kernel version that supports the next version of Windows Server, and that runs in isolation mode. So when you delve deep into certain system calls, you'll hear of running isolated containers, where effectively it's the kernel and your container that runs inside Hyper-V, completely outside the normal system. So Portainer is a little app, and all it does, it manages my containers. So I can now update my containers at will. So if I click on, so that's my one instance, which is local, which is on this machine. Now this is a droplet. This is a DigitalOcean droplet. Not a very strong one. It's only got 4 megs of RAM. Couldn't afford anything else. And this was the use case for the SQL. It kept on dying on me. So I had to, there's a flag, you can tell it to recreate or restart a dead container. So you can always, so it's called a restart policy. You can really tell it, when you die, start up again. And that's what I had to do on this. So these containers have been running for, there we go, see, that one stopped. Right, stop. These containers run 24/7, all the time. That's my SQL database, over there. I've got a SQL database, I have a web app, and I have a .NET API app over there. Portainer itself is running as a container, and I'm talking to the container. So you'll see here, I'm hosting it out on port 80. Sorry, no. No, this is port 80 and on 9000. Okay. I can do it on all of them. Whereas this one, there's port 80. So internally it's port 8090, but outside the whole world it's port 80. That's why I can do it.
So they've always got like a NAT layer on the image that.
Yeah.
Yeah.
And that's quite useful if you actually specify that, so you can tell it which ones to use. So now if you write code, you can
within your Docker file, not your compose file.
You can run it in a Docker file, you can run it, you can tell your Docker file to call a PowerShell file, a batch script, whatever you want to do. You're the author of it, so you can, if you can do it in command, then you can do it inside the Docker files. Yeah. It's just a nice little use case. These run constantly. When they die, I have to come in now. You can keep them again. Just a little side note. The reason why TeamCity stopped, I was actually running my builds inside containers, inside TeamCity, on this machine. Just to show you that there's a lot that you can do with these things. This was pretty cool. I was building the UI app. Cool. Come back here. So exit will exit out the container. Just exit out any. So in this command, we're going to detach, run SQL, you're going to name it the word SQL. So you'll see this as well. This happens often. There's env or -e, and the key value pair, those environment variables. Very powerful, because when this container starts up, it sees this value. Now in .NET, they've made it very easy now in the framework to interrogate these variables. So you can have your code executing different contexts very easily. So there I'm setting the environment variable. SQL by default, when you install SQL even today, native on your machine, the little window box that says, do you accept this EULA? That's what that is. So it's just passing them. And then passes the password, SQL password. Super awesome, secure DockerCon, exclamation, exclamation. See if we can get this thing going there. Just as caveat, dash dash detach, same as dash D. All that's going to happen is it's going to release the console from the container so it can continue executing, and that's how you run it in production, as a detached mode. You can reattach once it's detached. If now it's running and you want to see what's happening inside the container, you can attach to a running container and you'll attach the terminal back into the execution. You can see what's going on. There's another one which we'll show just now. It's Docker logs, and that will pipe out the logs that are piped to the executing command. It won't just give you any fictional logs. So whatever executable is actually piping any logs out to the console, that's what you'll see. So let's run this again. Dash detach. Gives you that GUID. Once that GUID goes back to the command prompt, then the container's running.
Basically, we've just started the SQL Server.
Yes, exactly that. Takes a little bit longer on this machine, but yes. Now, if you think about how you treat SQL, conventionally you would think, oh, SQL is this whole installation. I need to dedicate a whole machine to it because I need to run this one database. If you treat SQL like a normal application, there's two components. There's the MDF file, which your data lives in, and the other one is the actual infrastructure, which is the running executable, right? They can run separately. So that's why this works, because nothing stops me from having -v, mounting a volume, and then once it starts up, I can have another SQL script or PowerShell, whatever, that says, when I'm finished, attach this MDF file, and there I've got my database.
Okay.
Which is pretty cool.
Would you use it on a daily basis? Like, let's say, obviously I'm doing work, I've got a couple of databases on my local machine. Would I use it for that? Or, is it worthwhile doing that?
So, those who know SQL know that it's memory hungry. So, in normal running environment as a developer, if I do, there's a couple of scenarios where if you're a developer and you run a lot of Visual Studio instances, you don't really want to have a lot of SQLs that you're not using running around on your machine. So in that case, you would start them up and stop them. Okay. And you would volume mount so that you don't lose that data. Sometimes it is useful to have the data inside the container though. Because say now you want to run some integration tests or some unit tests or whatever like that, and your data needs to alter during that process.
Or you just need to recreate the same data over and over.
Exactly.
So
NC Framework has a nice seeding way of doing it, so you can seed out your data, do your tests, and then when the tests are finished, you have your outputs, but your data is gone because you don't need it anymore. Side little caveat, if you've done unit tests inside .NET Framework or using EF, that's exactly how you do it. You write your data layer into memory, and then you run your unit tests against it. So, yeah. And folks are Docker, yes. Here's my SQL. I have SQL in.
So, I don't know if I'm speaking too soon here, but how does this look at an architectural level now? I mean, you've got this concept where you've got all these containers you can do their own thing. They attach to, forget whether it's Windows or Linux, doesn't really matter what the host is, but you could almost have one effectively supercomputer where you're writing to SQL files in C/SQL, MongoDB in C Mongo, Elastic in C Elastic, and the containers all running as the process spaces. Is that how an architecture works, or do you split across multiple hosts where containers run on some? I'm not quite getting it.
So remember that little funny multicolored rainbow graph that I showed you earlier? When you start off, that's exactly where you're going to start.
Just one
90% of the time, that's where you're going to start off.
Okay.
And even as a developer, that's exactly where you start off. But as you start migrating over, you start seeing certain things that happen because you're still bound to one reality, and that is your machine.
Yeah.
So if you have all your containers on one machine, your point of failure is your one machine. So yes, you could easily do it on a supercomputer. It kind of loses the point of it. You want to scale that out, and the easiest way to scale it out is to move to different hosts, to pawn it off.
But on cloud infrastructure, where all your disk and I/O is shared resource anyway, do you get benefit from having multiple hosts in that environment, or is it?
Because when you have outages on certain hosts, because even on-prem, if you have an on-prem cloud infrastructure, you need multiple hosts to be able to do that, to achieve that. You will always have outages on hosts. And then, so if it's in a container, you can easily move them between hosts. So say now you want to upgrade a certain VLAN, you just move it over, upgrade the VLAN, move it back again. So do V-shifting or V-motion stuff like that. So I'm going to leave it here. We're going to do the little county thingy. We'll ask the question. We'll do the county thingy, give out 2 prizes, yay! And then Gordon's going to do his thing. Okay.
Another thing to remember with the web super easy. Often with the web-based apps, your various contention areas your network. So although you've got this machine that's got so much CPU and so much RAM, your network's a bottleneck. So you want to scale out generally on like smaller sized machines, but just for the network IO.
Yeah, although that if you have different applications and one is memory hungry, you put it on machines that have high memory and separate applications that need just IO.
100%.
No, but that doesn't work with the container because you assign the memory to the container.
But you can scale your memory to your container. So
Yes, no, I get that. Yeah.
So what you might find is even though that let's use SQL. Say now your SQL is your devs or your production guys are saying the database is slow performing. We need to up the memory. Nothing stops you from changing the policy for that container. So nothing changes the container. You just up the RAM. But again, you're still in the boundaries of a certain machine. So you've taken the RAM from one container and given it to your SQL container. So you might want to move that your other containers that don't need that RAM, move it to another host that has the available RAM.
Yeah,
You can give it to the RAM container. And like Gordon said as well, networking and a couple of things. So high throughput containers you're going to have on a certain VLAN where you can talk to the chatter is very nice. The ones that like you're logging, you don't need on the same.
Yeah, and I get the physical constraints. I guess my question is more, I don't quite understand how you decide what goes where, because you've kind of shifted so we've come from a world where we had one physical box where then we mounted 15 virtual machines on that, and we were restricted by physical. Now we put in containers within the virtuals, and yeah, I'm not quite sure of how you...
I can answer that for you because I did a presentation specifically on how the infrastructure would work with containers. So in the traditional world, we had segmentation where we had physical servers and we were segmenting our network based on physical workload. So we had a web server, that was a physical workload. We had a database, that was a physical workload.
Yeah.
Then we went to the whole virtual world where we started doing nano-segmentation, which was essentially having multiple virtual machines that perform a certain function, for example, databases, or sitting in different virtual machines moving around. Now with containers, we have another concept called micro segmentation. Okay. You can actually move by application workload, manage containers at that level. So for example, say you have a web app, and that web app is relying on an API, a front end, and a database. You can shift all those components in their own containers and shift those 3 containers as a workload wherever you want. So now you're not actually shifting a virtual machine, you're shifting just that application and its workload wherever you want it. Like Leo was saying, if you want to move an application that's really resource intensive on database, but you still need the front end and the UI working with it, you can actually move those 3 containers to another host, just that workload, without affecting anything else. So you're basically giving a more granular layer to how you can actually segment your network, how you can configure your applications, how you can configure your infrastructure. So you're making it more and more granular, easier to manage, but also a little more difficult to manage because it's difficult to inspect into those containers and actually see what's actually running. But yeah.
That is one thing that's putting off, is there's no GUI, and I'm a GUI guy. Like, I need to see.
No task manager.
Yeah, like going to SQL, like I need to see what's going on there. Like I need to, like I can't.
That being said, you can still touch SQL. You can still, if you've got a host that's running SQL Server, yeah, you can touch the manager. You just got to pop out that port and expose that container out so that you can actually connect to it. Same as with Windows. I've actually done it where you can run a Windows container, Supercore container, and from another machine, remote into it. and attach a GUI. Through a remote terminal session using something like TeamViewer, or OTS, or something like that. So you can still interact with the container, but the GUI is running outside.
Yeah, okay, so you need some different container with a GUI on it to get into that.
You don't necessarily have to have it in a container, but yeah, it's possible. And the GUI does make a lot more resources. The whole point of this is you running the processing application where UI takes a lot of resource.
You're basically just scrapping that away.
Essentially, yeah.
So what Mark's saying is 100%. There are other, in the production world as well, you can get some tools that actually surface a lot of this gooiness to see what's actually happening.
Yeah.
So Datadog is a nice one. They're expensive, but they're a nice one. There's a couple of providers. Sumo Logic does it as well. So Sumo Logic does, if I have a VM and I want to see what my containers are doing to my VM, Sumo Logic is a nice way of doing that. So it has an agent that actually runs on the host, and whatever runs inside those containers, it actually pipes those logs out to a central interface, and I can see it. I can make decisions with it. So to answer your question is, why would I do it? Or when do I know when to do it? When you start off, you don't know. You don't know what you don't know. When you start learning what's actually happening to your, because remember when you're running VMs as well, a lot of this it gets bled into the VM itself. A lot of it's performing badly. Now I have to get a whole bunch of diagnostic tools to try and interrogate what's actually going on over here. And if you're not very good at what you're doing, then you don't really know what you're looking for until it hits you in the face. And when it's on an application level, then the app, easy, I switch off the application. My website, my database, and everything is off. Everything else is running. On the same host, everything else is running. Oh, now all of a sudden I've got 5 gigs of RAM. Oh, there we go, there's a problem. Now we spin it up again, and we start interrogating as well. We start seeing what this process is. So it is a bit of a different mind shift, but there are some GUIs like SQL Management Studio can connect to a SQL container. And then now you get, especially now with the new one, the new Windows SQL Server, you can actually do profiling on it as well. So you can do normal SQL profiling and see what's taking over. You can't, technically you can RDP into a container. You wouldn't want to though. It's a bit of a magic voodoo trick to do it, to actually see what's happening inside my NanoServe or Windows Server or like that. There's a way of doing it. It's kind of Port voodoo to get it working. It is possible. I've seen someone at Microsoft do it. But technically you want to, and that's why you start with a big graph. You start big, don't really know what you're doing. You start sliding across, you start breaking the pieces down, the Lego pieces. When you got the Lego pieces down, you can switch off Lego pieces and see exactly what's going on. And that's how you Any other questions? Any other comments?
So that as well, you'll find that you'll get better at logging stuff because of that blindness that you looking at the whole machine. You'll start using like all those different logging frameworks to aggregate all your logs between different systems, because that's now a blind way forward. I mean, I just find that like talking about containers and stuff, like Google have a policy that they don't run anything that's not a container. Their whole business goes, they're not down to like any software that doesn't run inside a container because of the flexibility that it gives.
Well, side note, I know there's 2 MVPs there. If you don't know what to log, Application Insights is the best, one of the best frameworks to use with running .NET code. You literally put a configuration in, and if you don't mind the logs going to Azure, it just pipes it all through. And you can easily see what's going on. Again, this is if you've got your own code, if you've got legacy code, that was one of the best ones that I found was the easiest to set up. Cool. So I'm going to stop there. I'm going to leave this. I'm going to put this on the meeting notes. You can go along there. What happens after this is you actually clone a repo, so you can actually set up Git on this. Inside here, it clones the repo and it runs the Docker file and the 2 Docker files, and it actually spins up the container and it presents to you the container ID inside the container. That's what it was going to do. It was just a nice way of showing execution. That's what it's going to do. Right. Just go to Google and do a number generator. Looks like we need it.
You don't want to have this sitting on your bare metal and your object.
So essentially the whole concept of the way I see it, I want to like infrastructure when you're running like full service. So you've got physical posts.
Oh, yeah.
Half of that, not operating.
Yeah.
Other than half of us.
Okay.
It's 20. No, there's 9. And
So you got numbers 1 to 18.
granular, essentially.
I wouldn't be surprised if this is on.
You know, when you get
It's too cool.
you can actually actively looking at
12. So number 12 is Dave.
more resources for
How do you say that name?
These
Samela. Right? Summerling. Who's that? Is that you? Oh, awesome. If that doesn't fit, well done, well done. If the shirt doesn't fit, let me know. I've got okay. You must take a photo. Yeah. From big to small.
your base server.
I'll go the bigger size. I'll go get them. Alright, and then so we're given a couple of these. For those who aren't going to get one. It's a Docker drinking cup. Right? Thanks for Obsidian. Some stickers. This one I'm giving a Rancher book. That one has a power bank in it. And there's 1, 2, 3 t-shirts. One from Rancher, one from GitKraken, one from Docker, and one from Obsidian that has Docker on it. T-shirts. Okay. So this is all sponsored stuff. So that's why we have sponsors. Cool. Next one.
Next sponsors.
Number 6.
Hey, that's me.
Monet Fund Sale. There we go. Check out that. Awesome.
I need my number. Do I need to go and do this thing?
So you're going to take a photo?
Do I have to?
Yeah. Gordon over here. There we go.
Oh, thanks, man.
No problem. First time out, you come.
Yeah.
You're going to do it that way.
We're going to be this
Oh, klein is voor de foto's achter.
Again. Cool. Thank
Thanks,
you.
man.
Thanks a lot.
Thanks very much.
Cool, man.
Cheers. To the sponsors, thank you. Good to hear.
So for those who don't know what a GitKraken t-shirt looks like, this is what it looks like. Yay! Oh,
Come on, guys. Thanks, man.
You need a t-shirt cannon.
yeah, sure. There we go. Yeah. Oh,
The
there we
blind
go.
flowing.
Come to our next one, we'll have some more. I'm going to hand it over to Gordon. He's going to do his presentation on what are you doing? Azure.
Yeah, Azure DevOps, some Docker things.
But
You
first
might be
we're
saying let's
gonna take a break and eat pizza.
So if we can take like 5 minutes, chow on a pizza, have something to drink, think of some questions for Gordon.
I mean, maybe I've got, I'm running like a regular setup, one server for INS on it. So,
Do you need, are you going to use yours? You're going to plug it straight in?
Yeah, hopefully it works. It doesn't.
all the same, stripping all that down, and then you run a very limited running, whatever,
some form of
half a mile, but it's probably like a manager for version.
Exactly, essentially. So the whole point is now instead of running, or where I see it going with the whole service, is instead of running a couple hours on your virtual machine like that, you just run traditional containers. You don't need this heavy, we say heavy in context of going from a physical server to a virtual machine or going to a virtual machine or resources. Now going to containers is more granular, so your virtual machine is still fairly heavy.
So I would then, if the one who does it 4 hours will run on
And you can actually add your own specific, so there's nothing actually taking place. adding all the dependencies you need and saving that. It's all about getting to the options that you want. So the whole point is you can run based on, you can have a full English solution. And this is like the kind of content you want. You don't have barely anything, just the burn on, and basically yes, essentially. But now you need something for that application to function on. Containers can be run some processing space to actually post that application. Whereas if you just like an actual application you call it, you need to have something running on something. Container essentially is that pattern running on it. So you can have a main image and it's like, I have all this information, dependencies, DLLs, done the framework, etc. I have all this information, spin up a little image or a little container. Your application synthesizes it, just making reference to certain dependencies, but I'm container. But then the other one. No, you swap this one. This one. Because that's the block of code that was behind it. The dog will pick it up. Yes. Yes. So you can do it in a lot of different ways. There's so many options that really depend on what you want to do. So you can use any form of one application like packages or like that. Okay, so you can have an basic one that you have to check it out, roll that image down, and then one thing, okay? You can pull from other repositories, or you can pull from your own, you can create your own. That you can go to the public registry, you can say, I want a copy of this image, it copies that image to your machine's flow. You then spin up a container that's referencing that image. Yeah, so for this feature in the container, what do you want to do? You can then, depending on what you do, you can go and say, okay, this is the container, I've got my application, my PowerShell script, or
so when I control, put all these DLLs in the building,
into the container, that it
can say,
essentially it will function as a raw application on your PC. Everything is just in the container. So the other thing you can do is only going to be an house to it. So I'm not sure if it's about administration with a lot of information. But what you can actually do is you can actually build an application from Visual Studio to build as a container. Spin it out and say run.
But you're not running continuously, so you probably build something big. Maybe put that motion.
So what we have to do
Yeah, exactly. And the last thing is, you can push an entire container. Your application gets an entire container. You can push an entire container to your pipeline. You don't actually have to just run a container machine. The last thing is, if you've got a container in a state reference something and you install it in your machine, no matter whether it's your room sheet or it's production, it will function exactly the same as long as it's referencing. So if you put it on your machines, deploy it to a test, to your dev environment, it references that image with the profile, it will build it in the exact same way you do the exact same reference.
The example here of Node is you've got a team of 20 developers and you all got these guys. And I want to build one web service, but it uses Node. So I can build a Node, build my container, and all the other guys need my web service because it's part of the app. You give them the container. They don't need to install Node, they don't even know how it works, they don't even know anything. They just got to run the container and it just works.
And the last thing that happens as well is it goes away from working on machine. That's never going to happen now.
Yes, yeah, it's run with Docker.
Yeah, it's always going to be running the same context. as long as you push the contact. No, yeah, we say that, but you know, it is true. But
Yeah.
from our
Yeah, that does seem to be true.
yeah, it's that short, so that's not enough container. You pull that same container, it pulls
It's like for me in the short term, if I wanted to build something, I would probably post it on one of
I had to change my slide. Dude, I had to be a steer.
They kept on saying the wrong words, and you know, drop the feed, when you see it writing, because it's too small. And it didn't update everybody else.
somehow essentially 80%. Starts off at like a gigabit. Yeah, you run Windows Chrome. Chrome is exactly that. It's exactly what it's in. Chrome reputation is it's having something. That's exactly well, threads catching us in a very unique way. I mean,
Yeah, because it needs to be tag. Tell me that.
Yeah, and essentially, I mean, you can always bring it back. That's the one it's still there in the background in your history, essentially. It's you can bring it back up and you can use that same history on that same
When he pulled down that image, so you pull down the nanoscale and you do what it needs to do to make it custom to you. Do you know what it has to do? So the image is sitting there. This container is using that image and customizing the field and a separate file. And that separate file you can share with anybody. They don't need the core image.
Well, then we need to break the core image. So it's a core core.
And will Docker pull it down itself? The answer from your question earlier, you said they're all using a common subsystem. So that's the image. So they need the image to run a container.
Yes.
Okay, I understand. Almost like a NuGet package to Docker. They need the image, and that's all the basic DLLs or whatever they are. Look at this, really. It's like we were 10 years ago as virtual machine.
Now we're going.
Yeah, virtual machines are virtual machines.
When I started working at VCD, I thought virtual machines are the future. Now things coming out now.
Yeah. But maybe we're so skeptical about virtual machines and
Well, that's one thing that I was something like, oh, you don't really understand. I mean, at the moment, AWS, 99% of the work that
we're all going to go their way. There's no question. I'm afraid. It's like, your infrastructure is going to die. Over the next probably 10, 20 years. I haven't read about it.
This is my first intro to Docker. I've obviously heard about it. So I was
Yeah, exactly.
So it's like I care about it.
It's kind of like Vsphere.
So when you have that, would you install that on your own? Or would you don't have that services?
A lot of people who are Amazon, well, you know, already connected in the background for them. Exactly, yes. But you can install Kubernetes. If you really actually want to download photos or Well, it's basically licensing, essentially. So, you've got a Enterprise license. They give you full access to your room.
The dock license.
So, like that mini. So, like, I have one that
That's a fully public. That one is public. You can, if you build it, as long as you have your in-house license, you take it, you build your own system. And then you can basically with your own enterprise license and your own advanced, your own source code, whatever you do inside, and that's basically volume license. So if you've got an enterprise license, you've got volume license for that. Obviously, with the public, there's only so much that's in there. So the way that Microsoft is going to release it, then they might not give you certain features. Then you can get
so they might give you like
as an example, yes.
So, I mean, you could run the NanoSense for free, and from what I understand, you could run a community version of Docker and run the NanoSense within that. What's the community version? And there's no support.
Yeah, you don't get support and it's not supported for infrastructure. So the community just uses the local community mass. Enterprise edition.
There's not a legal issue, it's just a scale issue.
It's a standard implementation of
Kind of like Elastic.
It's based on how far you want to go. It's like, it's a workstation to do all this stuff.
Yeah. It's like the old stack. I mean, it's all free, but there's no auth unless you pay. There's no authorization. You can't secure it unless you buy the enterprise. It doesn't sound like much, but then you work at a financial services company and you realize that's the thing. You actually screwed. Like, so you end up, you can use it, but then you end up locking down your machines and it becomes such a mission to use it.
That has brilliant. No production that changes. That has to change. So you can be guaranteed that the increments code and the hash matches you can be sure that whatever you put in that hash tested, other people touched it, you can be sure that it's exactly the same. And also makes it kill. Someone else injects someone push something that happens. Feel like I'm having to push something you wish like that. Soon as someone trusts me, it's a huge mind. We're giving another RPA address for automating this new hash back. And unfortunately, as a that's constantly changing. It's very, very difficult to try and all in one. Yeah, exactly. And every time I try to touch it, it's just like, no, kill it. So I can't even so essentially, I think you can usually open doors infinitely until you get to the end and you're like, well, I'll go back.
Yeah. Well,
Exactly, yeah. And then also really, really take the time to call them, but scale up.
that we talked about?
Scale based on what that service is. We serve multiple applications, but it's a big server. If you just got a figuring out some application a specific work that you found for a specific service. So it's have a database and so I just want that service to say I'm multi-copy that service from the same database. The service itself. That's just say like don't scale any type server. Multiple containers. Yes, you have multiple containers. Each component to run it. That's the ideal virtual case. But everything is modular.
So like, you won't have, like, if you can't do that, for instance, if you have your web server and your SQL server, you have your web server and your SQL server in one container. You can't say take this event and split this out. Just do that. You have to upfront have your different servers.
You were saying if you have to get more focused at that point where you have really running one.
Yeah,
And then as you get more and more, you realize, okay, this
just integrate this out, you take that out, you do the same thing. Communicate like that.
and then at each point it can be scaled by itself.
And dynamically scale. So like a simple one, like SMS, you're going to send an SMS, and most of the time it doesn't got 100 a day or whatever, but then you do a slight pay and there's 60,000. So if it's coming in a queue, you just suddenly spawn 7 or 8 SMS containers, and they're all just reading by the queue, and then you scale back down to 1.
What was like a game day?